Hello, thank you for joining. Let's maybe give it another minute until everybody has the chance to connect, and then we can start. All right, I think that should be enough. So hello everyone, and welcome to our webinar, NoSQL security scanning, finding and remediating MongoDB injection vulnerabilities. First of all, let me introduce myself. My name is Sven Morgenroth. I'm a staff security engineer at Invicti. And today we will focus on three areas. First of all, what are MongoDB injection vulnerabilities, the secure development practices for MongoDB, and how to scan, analyze, and fix reported vulnerabilities with Invicti's help. Now, before we dive into the presentation, I would like to quickly introduce who we are. Invicti is a global leader in web application security since 2005. And we are set up out of the unification of two companies, NetSparker and Acunetics. Now, a few fast facts. Our head office is in Austin, Texas. We have more than 400 employees, 3,600 customers, and we secured over 800,000 applications, and our net retention is at 111%. We provide web application and API discovery and testing that is accurate, automated, and embedded within the SDLC. And we offer three types of testing technologies, including software composition analysis, or SCA, dynamic application security testing, or DAST, and interactive application security testing, or IST. And all of this can be automated throughout the SDLC. So what are MongoDB injection vulnerabilities? This is what I want to discuss with you today. It's a vulnerability class which is relatively new compared to the staples in web application security, such as cross-site scripting or SQL injections. And yeah, so MongoDB is by far the most popular NoSQL database, and currently the fifth most popular database engine overall. It's also widely known as the foundation of the mean and MERN software stacks. This is for building full stack JavaScript applications. And technically, it's a document database type that stores its document in JSON formats. Now, similar to traditional SQL injection, MongoDB injections rely on unsanitized user input and are performed by entering payloads that modify MongoDB queries. And you can kind of distinguish two different types of injections. There's, first of all, an attack where you would inject MongoDB operators into a vulnerable application. And also, you can inject JavaScript into MongoDB queries. We will take a look at both of these scenarios within this webinar. Now, what is the difference between NoSQL and SQL? NoSQL databases are a class of database that is clearly separate from traditional SQL databases. That is because they don't have the classical relational tables with a clearly defined structure. but instead they have a collection of documents that don't need to have a fixed schema and can be queried based on the properties. Also, the scaling works very well horizontally. The only thing you need to do is adding a new server to a cluster. And in general, traditional SQL is not as fast as NoSQL queries, especially for key value storage. And of course, they also don't use traditional SQL syntax. So many people assume that the lack of SQL also means that vulnerabilities like SQL injections are impossible in a NoSQL database. However, that is not exactly the case. While it's not SQL, it still has its fair share of injection-style vulnerabilities, often referred to as NoSQL injections. All right, now NoSQL databases aren't vulnerable to traditional SQL injection attacks. And in the past, there was a lot of issues with MongoDB databases being publicly accessible. There was no authentication, and the reason for that is that initially the way that these databases worked in the past was that they were on the same machine as the application, and the documentation wasn't very clear about the necessity of activating proper access control, which contributed to a lot of misconfigurations and big data leaks. And there were other issues as well. For example, the REST API, which was vulnerable to cross-site recursive forgery attacks. And sometimes even these REST APIs were available without authentication. Most importantly, though, even though it's not suffering from classical SQL injections, a MongoDB database can still be exploited with no SQL injections. And these are a type of vulnerability that lets malicious hackers introduce or inject undesired code into database queries, which are then executed by NoSQL databases. And these are as severe as classical SQL injection attacks. You can rechange or delete data and even leak some information about the target system. So usually there aren't any classical injection attacks possible, at least not in the MongoDB operator kind of attack. So as you see below, there's no in SQL injection attacks, you would have this structure that you can break out of and alter the meaning of the query by just putting in a string. But that doesn't work in NoSQL injection attacks. Instead, they take advantage of the unique way in which data is passed to the database. So this is not done with a string usually, but with an object that contains the selectors for querying the database for the required information. Here we have a user called admin and a password called password. And if we are using this query, it will only match the document where there's a user called admin with a password called password. And so you could not get the admin user without knowing their password. But what if we don't know the password and we're like a malicious hacker who wants to authenticate against the application? The way they could do is using operators. These allow us to clearly define the desired output with conditions such as equals, does not equal, or even regular expression searches. So in other words, we pass an object instead of a simple string or number and have an operator as key and a condition as value. Now, in the above example, we can use the $NE operator, which is an operator that means not equal. So in this case, we can just pass $NE as a key and X as a value, which will query every user who has the username admin and a password that is not the literal string X. So now this condition will match because X is not the password of the admin user. And therefore, with this new operator, we were basically bypassing the authentication check without knowing the exact password that the admin user has. Now, here's a very simple example that accesses a MongoDB database to perform authentication. This is how it may look like. The username and the password are directly used without any form of safeguard or filter, which may be vulnerable to the operator injection we have just seen. Now, what we want to do is we want to supply an object that contains the $NE operator as a password with the letter X, as we've seen before, or like any other input. And the question is now, how can we do that in a real application? Because usually you only pass strings with the $_post variable we've seen above. And actually, it's kind of simple. All we need to do is supplying the malicious request that you can see on the left. We can use the square brackets to either inject arrays or objects. And in that case, we can use the $NE operator again, which as we already figured out means not equal. So if the username is admin and the password is not foo, we can just log in. But that's not the only operator. There are a few others that we can abuse in a similar fashion. Some of them give us some extra abilities, like the regex one you see on the right. With that, we can slowly enumerate all users of the application. For example, the below username regex equals, and then like the start of the admin username would still match. So we could just use this to log in as the admin user and therefore like enumerate different users, or just take over the account of a random user if we want to. Now, let's take a look at another example that we haven't talked about yet. There's also the possibility that you can use JavaScript in MongoDB query. This is commonly done with the $where operator. And yeah, so above you can see an example of this. When this .name equals the name that we supplied, it will return true. So we can search by name, but if we don't know the name, then we can't really find the document in the collection. And this may be a literal name, it may be an ID or anything you can think of, maybe a GUID that is random and pretty much impossible to guess. But here we can actually use a similar approach as with an SQL injection. You can see here that we can just modify the query in a way with our input that will always return true, no matter what the name of the document is or the ID is or whatever. And because the result is always true, we will receive the entire list or like the entire collection of documents. And yeah, this is it's also possible to abuse this for denial of service attack, for example. All right, now you may wonder how to detect NoSQL injection vulnerabilities. And the best course of action really depends on your environment and what kind of application and software you're using. If you use commercial or open source software and do not develop it your own, you can use SCA, which will basically show you whether or not you are using outdated components in your software, or your software is outdated in general and has known vulnerabilities that you may want to fix, for example, by applying patches or updating your application. If you develop your own software, that's not possible because the vulnerabilities, NoSQL injection vulnerabilities, for example, that you may have can be considered 0 days because there's nobody that knows about the vulnerability yet. And because you developed it yourself, it may only be possible to find the vulnerability by actually testing the application. And for that, the best course of action would be a penetration test or the use of a DAST such as Invicti. Now that we got an idea about how attackers abuse NoSQL injection attacks, we may take a look at how to actually prevent them. There are a few secure development practices for MongoDB. You can see them here. One of the most important ones is that you sanitize user-controlled inputs. And of course, you should do strict type checking for your user input. If you're expecting a string to be passed to your MongoDB query, then you should actually check that the user really supplies a string and not an object, or maybe you expect an integer, and you should do the same there. Just ensure that the type is correct. You should also avoid insecure MongoDB operators and commands, such as the where operator we've seen before. And if it's possible, if your application can do without it, you should certainly disable JavaScript in the MongoDB configuration. We'll see how to do that a little bit later in the presentation. You should also ensure that you're always using the most recent version of MongoDB and any component in general. And if you have a vulnerability and fixed it, you should retest it to make sure that the vulnerability is actually fixed. Now, let's take another look at an example of a NoSQL injection. Here you can see a code snippet from the intentionally vulnerable OWASP node goat application. And like one thing that will immediately get the attention of an experienced pen tester, and probably now you as well, that you know about the dangers of the where operator, is like the fact that there is JavaScript code in the where operator that uses dynamic input. From the name of the variables that you can see in there, you can already guess that the user ID is passed in some way. And in this case, it is actually casted to an integer. And next, you can see the threshold parameter, which is not passed in any way. So it's directly used from unfiltered user input. And as you can see, again, this is very similar to SQL injection attack, classic one. You can just inject a string instead of only a number. And therefore, you can basically control the return value of the operation here. And the way this works is this would go through the database and call the JavaScript function you can see here for each document in the collection. And since this always returns true, it will just return all of the documents. So how does OWASP suggest that we should fix this? Now, the suggested solution here that you can see in the comment is focusing on input sanitization and validation by casting the threshold parameter to an integer and then checking if it's between 0 and 99, which is good. There's nothing really wrong with it. You can do that, and you should, as we've established before, ensure that all of your input is of the right type. But then again, it's using JavaScript, and even like 1 year from now, you're adding another maybe another condition to this JavaScript operation. You may not know why there is where the threshold is sanitized like that, and maybe introduce a new vulnerability on accident. So probably the correct course of action here would be to still sanitize everything correctly and cast everything to an integer where an integer is required. Use the range check that it's between 0 and 99, but maybe turn it to into another kind of query where you don't have to use JavaScript. And you can see this here. This is the query that we eventually came up with. So this brings us to our next mitigation that we talked about before. You may be wondering how you can disable JavaScript. It's relatively simple. There's a configuration file named mongodb.conf. And in it, you can set the JavaScript enabled option to false. Unfortunately, true is the default. Just to make it as simple as possible to use functions such as where MapReduce, accumulator, or function. Operators, not function, sorry. But yeah, if you don't need this in your code, then you can just disable it, then restart the MongoDB service after you make the changes to the configuration file. Also, you should always use the most recent version. Using the latest version is important to prevent applications from being vulnerable to already published vulnerabilities. This is a general security best practice that you should always follow for all software whenever possible. Just so that you are secure from known vulnerabilities that may be exploited by attackers on a large scale, or just by specifically targeting your application. Now you may be wondering if there's a way to automatically detect these vulnerabilities, because especially if you have a large application that uses MongoDB, it's really hard to find all of the occurrences and trace every user input to the MongoDB query and see whether or not it's vulnerable. Now you can actually scan and analyze vulnerabilities with Invicti. And once you've done that, you can fix them and ensure that the fix actually worked by retesting the vulnerability. And we will now show you a little demonstration of how this may work in practice. All right, so let's take a quick look at how we can detect a MongoDB injection with Invicti. First of all, I chose my target. I chose a proper scan policy with the MongoDB checks enabled. And let's just see how it turns out and whether Invicti is able to find the vulnerabilities on the test page. So it's now scanning and crawling the application, and you can already see that it is trying various attacks for MongoDB. And as you can see over here, it already found some vulnerabilities. So this is an error-based MongoDB injection. I found that one quite quickly. As you can see, this is the attack patterns it used, and based on the response, it found that this page in particular is vulnerable to a MongoDB injection. All right. So let's quickly pause the scan. And what I will do now is I'm going to fix the MongoDB injection. In the background, it's still trying to find and confirm some things. And since I stopped the server, it now shows that there was like timeout from the server, but that was expected. We'll now fix these vulnerabilities, and the good thing about it is that you can immediately see whether an issue is fixed or not, just by clicking on it and then choosing retest. And as you see, everything is fixed. It seems fine now. There's no issue anymore. You can do that for each individual issue if you want to. That would certainly be a possibility. But if you want to check if all of them are fixed at once, you can also click here. And oops, sorry. You can also click here on retest all. And it will show you that all of the vulnerabilities that were previously reported, all the 12 are fixed now. And yeah, that's how you can detect MongoDB injection with the Invicti scanner. So this is the end of our presentation. Thank you very much for your time. I hope you found it helpful. So if you have any questions, feel free to submit them now via the chat functionality. And we'll just wait a little bit and then take a look at your questions and try to answer them as good as possible. All right. Thank you very much for your questions. Looks like we have quite a few. So let's go through them one by one. The first one is this kind of injection the biggest security threat for MongoDB? Do you know about other attacks which are also equally dangerous? And I would say that is one of the biggest threats, but the fact that there are still probably hundreds or more of MongoDB databases out there that don't have any form of authentication. I would say that this is equally as bad as the NoSQL injections. You should always ensure that you are not exposing your MongoDB databases to the open internet without any form of authentication, and ideally you should not have them exposed to the internet at all. You can still read in the news very often that somebody found an open NoSQL database that allowed them to retrieve a large amount of data. And this issue does not appear to get any better. So it's certainly still possible to do that mistake, and it's done quite often. So you should really check and ensure that only you are able to interact with the database, and ideally have it behind some kind of firewall, so only your application and yourself can have direct access to it. All right, the second question, are all these attacks and remediations you showed only for MongoDB, or does any of this apply to other NoSQL databases too? This is kind of generic. Of course, different NoSQL databases may have different kinds of operators, different ways to execute JavaScript. And yeah, they may be different in certain aspects. Also, the mitigation for disabling JavaScript will be different depending on what NoSQL solution you're using. But in general, the concepts I showed you today are applicable to other databases as well. And it's not only MongoDB that has these issues, but also other databases. So third question is, do you think NoSQL injection is going to become more important for security in the future than SQL injection? That's a good question. It's not easy to answer. The fact that there's now an effective way to mitigate SQL injections with prepared statements can really help to write secure applications. And I think developers are more aware than a few years ago of the dangers of SQL injections. So I think that in the future, SQL injections will not play as big of a role as they did in the past. I also don't think that they will completely go away anytime soon. But then again, the MongoDB and NoSQL injections are relatively new compared to SQL injections. There's not this this general awareness of the dangers of them. And many people still think that the fact that they are using NoSQL means that there are no injections. And so I would say that they aren't as important yet as SQL injections, but I think in the future this may actually shift, and that NoSQL injections may at some point be more prevalent than SQL injections are, and we should take care of not introducing them into applications and hope that there will be some similarly effective mitigation strategy that we have for SQL injections now. All right, then thank you very much for your participation, for your questions. And this is the end of our presentation. Thank you very much for coming, and goodbye.